Hello everyone. I wanted to show you this neat project that I've been working on. It's basically a digital piano that will output 4 different keys. So the way that it works is that we're going to have 4 different push buttons that are going to be inputs into this microcontroller, the TM41C123. And the microcontroller is going to have 6 pin outputs that form a bus, and basically they're going to alternate high and low signals that will generate an output signal. So the way that it works is using a digital to analog converter, and digital to analog conversion is just a technique that will output discrete signals, meaning one signal at a time, but it does this so fast that it sounds like a continuous signal. And so to talk a bit about the data flow and which is how the information passes through the microcontroller, let me see if I can scroll this down. Okay, so you're gonna have the 4 push buttons, and they will basically talk to the program through this piano interface. The piano interface will collect the information, and the main program will then send that to the sound interface. And the sound interface uses the sine wave table, which represents those discrete signals, or those discrete elements that I talked about, that will be alternately pushed through from the bus. And so the sound interface will choose which discrete signal it wants to output at that time and give it to the digital to analog converter interface. And then the digital to analog converter interface will translate that to the digital to analog hardware, which what you see is this set of resistors here. They're each scaled by half going down, and then give that to the speaker. So the last part of this is the call graph, which is how the software will interact with each module. So you see we have the main program, and we have 3 different modules: the piano driver, the sound driver, and the digital to analog converter driver. And notice that the main program only has access to the piano driver and the sound driver. The digital to analog converter driver is extracted from the main program through the sound driver. And so the piano driver will initialize our switches as inputs and collect the data from them, asking basically which button is pressed at a very fast rate. Then you have the sound driver, which also initializes the SysTick hardware, which is basically an internal clock in the microcontroller. And we'll use that clock to not only interrupt the system and call the DAC, but it will also, we initialize it in a way that will allow us to output different frequencies. And so what the DAC does is also initialize our output pins and sends information to the output pins about which pins should be high and which pins should be low. And doing this, it's pretty neat. I'm going to show you the hardware now, and you'll see that we can even make music with this. So here's the hardware. You'll see that each button has a key next to it. So this is the first key, the G, E, D, and C. And here at the top is our series of resistors that you saw in the drawing, and that output to the speaker, which has a little bit of noise there. Okay. And here's the microcontroller. Notice that I'm getting power from the microcontroller, and all my buttons are inputs into the microcontroller. So here we go. Maybe you might know this song, and I hope you enjoy. Thanks.